Hi everyone, this is Ramalinga Prasad Kuppa. Welcome to my channel, Pharma World. Today's topic is stability studies of pharmaceutical products, the intent. ICH Q1AR2 is the basic guide for conducting the stability studies of APIs and drug products. The intent of the study is to establish how long the product is stable and usable with an acceptable criteria of characteristics of the API or drug product. Let us understand the intent of the stability studies in detail. Let us see what the guideline prescribes. The purpose of the stability testing is to provide evidence on how the quality of a drug substance or drug product varies with time under the influence of variety of environmental factors such as temperature, humidity and light, and to establish a retest period for the drug substance or a shelf life for the drug product and recommended storage conditions. Let us understand the intent of stability studies necessity. The study evaluates how the characteristics vary over different temperature and humidity conditions. The stability studies also decide the shelf life of the product. To understand easily, it is how long the product is good and passes to the specifications. That means how long the product is alive for usage. Let us consider a real life situation. If a human being is exposed open in hot day on a summer day for about 5 hours, how that person's characteristics vary. This is high stress condition. He will sweat very badly, feel terribly dehydrated, etc. That means the characteristics are varying beyond specifications. The intricate stability of the person is in danger. Under such conditions, how long the person will survive? This is the real understanding of stability study concept. Under normal cool conditions, the life is comfortable on long term, is it not? So the stability study of drug substance or drug product is an indication on how the product varies in characteristics and how long it will be within the specifications. Let us understand what is stress testing. Stress testing of the drug substance can help identify the likely degradation products, which can in turn help establish the degradation pathways and the intrinsic stability of the molecule and validate the stability indicating power of the analytical procedures used. Now we know what is the stress condition. The product is exposed to severe extreme conditions to establish formation of any degradants from the molecule. Like for example, if a small amount of sugar is heated up on a hot plate, it would degrade and char. The original characteristics would change. Similarly, when an API molecule is exposed in extreme conditions, there is likely that some degradants may form. The basic idea of stress testing is to establish this fact. This is an indication on how the API should be packaged and stored without formation of any degradants. So this test gives good information on its intrinsic stability. Also, this exercise is useful to validate the analytical method's capability to detect such degradants accurately and repeatably. This method should be able to detect the degradants accurately. This also helps to find the retention times of such degradants so that they can be identified at any stage of analysis. Generally, a HPLC method is selected as a method for estimation of related substances. It is very important prove that the analytical method is capable of detecting these impurities. This is exactly the meaning of stability indicating method. This process will prove that condition. This point is very important. The nature of the stress testing will depend on the individual drug substance and the type of drug product involved. So, depending upon the type of the product, the stress testing will vary. Selection of stress testing methods from the list including exposing the product at higher temperatures like 50 degrees Celsius or 60 degrees Celsius, or at higher humidity 75% or greater, oxidation, photolysis, hydrolysis at wide range of pH, etc. At the accelerated storage condition, a minimum of 3 time points, including the initial and final time points, example 0, 3 and 6 months from a 6-month study is recommended. After the initial stress test, short-term accelerated test conditions have to be used for study. Conditions for short-term accelerated study for room temperature storage APIs are 40 degrees Celsius plus or minus 2 degrees, and the relative humidity will be 75% plus or minus 5. Here it is important to note that the room temperature means it is 25 degrees Celsius plus or minus 2 degrees. If the product storage conditions are between 2 and 8 degrees, the accelerated conditions are 25 degrees Celsius plus or minus 2 degrees. The relative humidity will be 60% plus or minus 5. Testing frequency will be 0, that is initial, after 3 months and after 6 months. So you get data for 6 months. If there is a varying trend between the initial and the 3-month study, it is recommended to carry out the study for 4th and 5th month also before concluding on the 6th month study. So if there is a trend for significant changes, that means failure to meet specifications, it is recommended to reschedule the further testing to include 4th month and 5th month also. It is a general practice by industry to carry out the study at 0, 1, 2, 3, 4, 5 and 6 months. To be on the safer side, it is a general practice to carry out testing every month till 6 months. Since it is done for a short period, this is called short-term study. For long-term studies, the conditions of testing should be sufficient to establish the stability profile of the drug substance. The stress conditions are reflection of intrinsic stability of the molecule. Remember the example of exposure of a human being on a hot summer day. The person may survive for a short period in such extreme conditions. But let us assume that the person is in a cool ambient temperature and humidity conditions or in a nice air conditioned atmosphere. The person will be comfortable for longer years, isn't it? Similar case is with the drug products also. Long-term conditions may vary with type of product. Some products are stable at room temperature and some are not, depending upon the characteristics of the product. For example, a sugar candy may be stored at normal ambient temperature. You cannot store an ice cream at room temperature. It needs a refrigerator. This is how it should be understood for pharmaceutical products too. So accordingly, the storage conditions may be at 25 degrees Celsius or 5 degrees Celsius or minus 20 degrees Celsius for freezer stored products. For drug substances with a proposed retest period of at least 12 months, the frequency of testing at long-term storage conditions should normally be every 3 months over the first year, every 6 months over the second year, and annually thereafter through the proposed retest period. I saw in several organizations the shelf life or retest period is being assigned arbitrarily as 1 year or 2 years or even 5 years. This is not acceptable. Data from at least 12 months is required for submission to regulatory authorities. So, if the product is manufactured first time at the manufacturing site, the shelf life can be assigned only after 12 months data and not before. The testing frequency is every quarter for the first year. That means after 3, 6, 9 and 12 months. From the second year, it could be half yearly. That means after 18 months and 24 months. From the third year onwards, testing is done yearly till the shelf life period. The guideline says if long-term studies are conducted at 25 degrees Celsius plus or minus 2 degrees Celsius and 60% RH plus or minus 5% RH and any significant change occurs at any time during 6 months testing at the accelerated storage conditions, additional testing at intermediate storage conditions should be conducted and evaluated against significant change criteria. Understand this carefully. Long-term condition study is conducted for 12 months and 6 months accelerated condition is also conducted simultaneously. If there is any significant change occurs in the accelerated study, it is necessary to conduct intermediate test condition study. What is significant change? The guideline terminology is anything that fails to meet specifications for drug substance. For drug products, 5% variation in assay, any degradation impurity beyond specifications, failure to meet acceptance criteria for appearance, physical attributes and functionality test. Failure of dissolution test is also considered as significant change. Intermediate test conditions are lower than the accelerated conditions and higher than the long-term conditions. That is why it is called intermediate conditions. So 30 degrees Celsius and 65% RH are considered as intermediate conditions. But there are more hot and humid climatic zones, Zone 3 and Zone 4 countries. They adopt the intermediate test conditions for long-term study. In such cases, there is no requirement to have intermediate test conditions. It is a good idea to initiate the exposure of sample packets at intermediate conditions also so that you don't lose time in case of any failure in any of the time stations of the accelerated study conditions. Whenever there is a failure at accelerated conditions, these intermediate samples will be readily available for evaluation. There are 5 climatic zones. The climatic conditions in various areas of the globe are different. To remember easily, most of the extreme north part of the globe comes under Zone 1. Just below that comes under Zone 2. The countries around the equator are considered as Zone 3 and Zone 4. Some parts of African continent and Asian continents are also considered as Zone 3. Long-term study conditions are given in this table. You can see they vary. Zone 1 and Zone 2 agreed for a common condition of 25 degrees Celsius and 60% RH. If the product is marketed in different zones, it may be necessary to carry out the stability studies as recommended by that zone's regulatory authority requirements. Data from formal stability studies should be provided on at least 3 primary batches of the drug substance. The batches should be manufactured to a minimum of pilot scale by the same synthetic route as and using a method of manufacture and procedure that simulates the final process to be used for production batches. The overall quality of the batches of the drug substance placed on the formal stability should be representative of the quality of the material to be made on the production scale. Mostly it is recommended to initiate the stability study on primary batches, which are submitted in the drug master file for any regulatory agency. It is necessary to submit the stability data of these batches to regulatory agency. Here the condition is that the product should have been manufactured under GMP conditions, complying to the quality management systems using exactly the same route of synthesis. So even if it is manufactured in pilot scale, these conditions should apply, because when commercial scale production is carried out, the quality should be same as the quality obtained in pilot scale or vice versa. The stability studies should be conducted on the drug substance packaged in a container closure system that is the same as or simulates the packaging proposed for the storage and distribution. These are other important sections in stability studies. The study should be carried out in the same or simulated package. Same package means exactly the same market pack. For example, a strip of tablets or a bottle of tablets are considered as same pack. But in case of drug substance, the same package will be in 10 kilos or 25 kilos or even 50 kilos denomination. So it is not practical to use the same package for stability study. So it is necessary to make a small package, a miniature pack with the same conditions of package scheme of the original container. For example, if the product is packaged in a clear LDPE bag, within another black LDPE bag, within a HDPE drum, the simulation should be done by taking same type of clear LDPE bag, black LDPE bag and a small HDPE container of suitable size. The stability studies should include testing of those attributes of the drug substance that are susceptible to change during the storage and are likely to influence the quality, safety and or efficacy. The testing should cover as appropriate the physical, chemical, biological and microbiological attributes. Validated stability indicating analytical procedures should be applied. Testing method should be capable to detect if there are any changes in the quality attributes. We discussed on characteristics of a stability indicating method in 5th slide. Testing should include any parameter that may change during stability study program. Physical changes, chemical changes or microbiological attributes are also part of the requirements. Tests like sulfated ash or heavy metals may not change with time under study conditions, but justification is required to that extent for deletion of these tests in the stability study. For evaluation of data, ICH-Q1E should be understood fully. Try to understand the intent of Appendix A of the guideline. This is very important guide for evaluation of data. After understanding the requirements as per Q1A R2, Q1E should be understood well. If the Appendix A is understood well, entire guideline is easy to interpret. Two important phrases: data amenable to statistical analysis, little or no change and little or no variability of Appendix A should be understood to interpret the data. Amenability means the data should be suitable for evaluation by statistical analysis. The numerical data should be available. In general, a minimum of 3 data points should be available for amenability of statistical evaluation. When there is data for 2 points in time, you can calculate how much change was there during the period. The result is expressed as a percentage and is called the rate of change. Variability is another word that should be understood. Variability is also called dispersion. This gives the information on spread of data. It gives information on how much the data sets vary and allows to use statistics to compare the data to other sets of data. Shelf life or retest period is decided by the data evaluation of available long-term data and the accelerated stability data that was carried out initially. This is a very important point to note. Shelf life cannot be extended to next time station of plus 12 months arbitrarily. The long-term data has to be evaluated against the data of accelerated data. Linear regression analysis is a good tool to predict the shelf life accurately. It is not very difficult to get into the hold to carry out the regression analysis. It looks complicated to start with, but after few practice sessions, it is really a wonderful subject for predicting the shelf life. Use Excel spreadsheet for such regression analysis. Based on the evaluation, the retest or shelf life may be extended. A detailed report has to be prepared with all this data included. Read section 2.4 of ICH Q1E completely and carefully several times to understand well. Because of constraint of time, all those aspects are not discussed here. Understand this table in entirety. The text here is in too small print. Refer page number 10 of ICH Q1E guide for more clarity. Then read the Q1E guide in total. When available long-term stability data on primary batches do not cover the proposed retest period granted at the time of approval, a commitment should be made to continue the stability studies post-approval in order to firmly establish the retest period. This commitment is important when you have adequate data on the product obtained from several published sources and knowledge on the product stability. You may be comfortable to assigning a retest period of more than 12 months at the time of regulatory filing. It is the responsibility to establish the retest period of the product and commit to continue the stability study till the proposed shelf life of or the retest period. Where the submission includes long-term stability data on 3 production batches covering the proposed retest period, a post-approval commitment is considered unnecessary. But adequate data is already in hand while submitting the data to the regulatory agency. Additional commitment is not necessary. Mostly the APIs are tested under stability conditions for 5 years and for drug products for 2 years. Let us suppose what happens next. After 5 years, does the drug substance fail to meet specifications? Really may not be true. Let us consider that the batch is tested after 5 years and found to be still within acceptance criteria. Then, can we extend the shelf life to the next time station of plus 12 months? Yes, of course. If you can't extend, you consider it as unsuitable for use. It is like giving a death certificate to a person who lived beyond 100 years who is still alive. So as long as the statistical evaluation is carried out and the product is within acceptance criteria, it can be extended to the next time station. The guideline says a storage statement should be established for the labeling in accordance with relevant national regional requirements. The statement should be based on the stability evaluation of the drug product. Where applicable, specific instructions should be provided, particularly for drug products that cannot tolerate freezing. Terms such as ambient conditions or room temperature should be avoided. The storage conditions should be same as in the stability study packaging scheme. storage conditions should be printed on the label. The temperature also should be specific, like store below 25 degrees, etc. Do not write generic reference like ambient conditions or room temperature. There should be a direct link between the label storage statement and the demonstrated stability of the drug product. An expiration date should be displayed on the container label. So, expiry date as derived from stability study should be incorporated on the label. I hope that this video program gives a detailed insight into the concepts of stability studies for the beginners. Read ICH Q1AR2 and ICH Q1E completely and carefully to understand the content and intent of the requirements. Thanks for watching. For more videos, please do subscribe, like and share. Thank you.